Hey, hello, how are you?
I'm fine, thank you. How are you?
I'm fine too, thanks.
Good to hear.
This device looks interesting. Can you tell me what it's capable of?
Yes, of course. What we can do with this instrument, by the way, it's the emtec TSA Tactile Sensation Analyzer. We can measure the three basic haptic parameters of fabric, textile fabric, which are the microsurface variations, softness, the roughness, which are the macro surface variations, and the stiffness.
Okay, you can measure softness. Oh, this sounds interesting. How will you measure the softness?
All right. In short words, it's a two-step measurement. And the first step we measure by a sound analysis. We measure the roughness of the material, the macro surface variations. And then in the second step, we measure the micro surface variations, softness, and the stiffness and some other deformation parameters. If you have a few minutes, I can show you.
Yes, of course.
Right.
Yeah, sounds really interesting.
Let me just take that sample out of here. All right. Okay. Yeah. Maybe first of all, some words to the instrument itself. What are the parts, the important parts? This is the measuring head. In the measuring head, mounted, we have a rotor with 8 blades. Right next to this rotor with the blades, we have a microphone. The second microphone is here in the measuring cell, on the bottom, and the rest around here is all a load cell, because not only noise or sound, but also the load or weight what we put on the material is important for the measurement. And then you have a third microphone. It's a noise cancellation system where we make sure that environmental noise is not influencing the measurement or the measurement results. Now, when we start the measurement, first step is the measurement of the roughness or macro surface variations. What we do is we put the sample into the device. So to measure, we place the sample right here. We close the fixing ring, and we close the handles here. Now you push start in the measuring software on the PC. The measuring head here would come down to the sample. With the rotor and the blades, we would apply a load of 100 milliNewtons on the material. Once this load is reached, the rotor starts to rotate, actually touches the material, over the material, and by this rotation, a vibration of the material itself is caused. Now, how does this vibration come? When we do the measurement, so when we apply the 100 milliNewtons load and when we rotate over the material, this measuring head is fixed in vertical direction. Okay. But the sample, which has a certain surface topography, needs to go somewhere, and it does this according to its certain surface topography. So, and this moving up and down according to the hills and valleys is a vibration at the end. And this vibration causes a noise, and the vibration is recorded by the microphone underneath the sample. And if you have a loud noise, which means a lot of vibration, means a rough material on the surface. If you have less noise, not so much vibration, means a smoother material. Okay. Now, after the measurement, the measuring head comes back up. The sample has to be taken out. The plastic film has to be removed, and only the sample has to be brought back into the instrument. Fixing ring is closed again. You lock the handles again. And now in the software, we push start, and the second step of the measurement starts. This measuring head here is coming down to the material. Again, we apply a load of 100 milliNewtons and start to rotate. And this rotation at this load also causes a vibration of these plates here. And now the vibration and the sound, which is caused by this vibration, now is interesting for us to get an idea of the softness or micro surface variations of the material. Now, if you would zoom into the sample really close, you could see single fibers sticking. And the blades are moving over these fibers, and if you have a hard fiber, it's hard for the blade to move over it, but once it passed it, it will get into quite strong vibration. Okay. If you have a soft fiber, it's easy to move over the fiber, and then the vibration will be so strong. This is like a stick and slip principle. And as I said, by this vibration, we get a sound or a noise, and if you have a loud sound or a loud noise, this means a hard material, because a loud noise means strong vibration. Strong vibration means a hard fiber. And if we have less noise, means less vibration, means a more flexible fiber, and this means a softer material. In the second step, we do a deformation measurement. We apply a load from 100 to 600 milliNewtons on the material. This gives us the in-plane stiffness D. Then we move back up. This gives us the hysteresis H and plasticity P, which are the recovery characteristics of the material. And then we push down a second time, which gives us the elasticity, or some call it elongation or stretch of the material. Very interesting, for example, if you want to compare, because you can also measure wet material with the instrument, so you can compare dry and wet sportswear, for example, and normally, you can see from the results, you can stretch wet material more. And this again has a certain influence on the quality. You know, how comfortable do you feel in the clothes? Yeah. So this is what you can do with the instrument and what happens.
Okay, if I've understood it now right, you measure some certain single parameters and then you have them each, but you don't get an information about the overall feeling. So if I move, for example, with my finger over the surface.
Yeah. Well, first of all, it's a good question. But first of all, I think it's important to understand let's say the advantages that you have by the availability of these three basic parameters. Okay. So like if you see a human, if you touch something, you also feel these three parameters with cells which are located in your fingertips or in the skin of your fingertips. But these signals are transported to the brain via the nerves, and they're combined to an overall impression without that you can influence it. Yeah. So it's happening totally unconscious. So we are not able to distinguish between these parameters. Now, but if you want to optimize a product in a certain way, you want to make it softer, but don't want to change any other parameter, humans cannot help you. And the instrument gives you this information. It gives you a separate or individual number for softness, roughness, and stiffness. And this opens up huge chances for process optimization. You can work on your product. If you have issues with your quality, you can use it for troubleshooting and see where this comes from. So I think it's very important to understand the benefit that these single parameters offer to a customer.
Yes, this totally makes sense to have these parameters also available separately. But is there a possibility to have some information about an overall feeling?
Yes, of course. We can calculate so-called hand feel values, which are like the overall impression of the haptic quality when a human touches something. So this can be done. Important is that this calculation needs to be adapted to a certain market and also to a certain application. A market specific because people from different parts in the world have a different understanding of what is a good quality, and this is because they combine these basic parameters when they touch something in a different way, or they put a different weight. Yeah, and like Asians do this different like Europeans. Yeah. So you cannot have one and the same product for both markets. It might be that one of the two markets wouldn't like it. So this is important. This is why it's important to have a market-specific hand feel calculation. Application-specific because you just expect something different. If you have a T-shirt and a jeans, the jeans needs to be stiff. But if you would have a T-shirt that feels like a jeans, you wouldn't like it probably. So totally this is the reason for that. Yeah. But when we have these specific algorithms for a market and for an application, we're able to calculate hand feel values that often give us a correlation of almost 100% to the human feeling, which is amazing.
Right. This is really amazing. And do I have to take care about sample size or something? Is there any requirement?
Yes, sample size recommend or should be like that 100 square centimeters as a round circle. It can be a bit smaller. It can also be a square. It's just this is optimal. Right. If it's this way, it's the easiest way to fix the material in the device. I think also important with regards to the sample to mention is that we should do 5 to 8 repetition measurements. So one is not enough, and you always need to take a different piece. This has it's also nice because you get an idea of how homogeneous your product is, but it also gives you a higher statistical safety to compare average values with average values. Yeah. So I think this is important.
Okay, our company also produces a little bit thicker material, and one of our products is also quite narrow. I'm not sure if I can fix it in here.
Well, you're right. Like very narrow material and also very thick material cannot be fixed in here. If you would fix too thick material in here, you could hurt the instrument, and narrow it just wouldn't hold. But you're not the first customer or interested person that is asking this question. So we ask our R&D to find a solution, and we have developed 2 adapters. One is this, we call it diaper adapter because it has been developed for the nonwovens industry for diapers. But tests with companies from the textile showed that, for example, very thick towels, which are very thick but still compressible to a certain extent, can be measured in here very well. Same thing. This adapter has been developed for femcare products, and but can also be used very well for seat belts, for example, yeah, because they are too narrow for being fixed in there, but you can fix them in here. What you do is you place a double-sided adhesive tape here, you put the material on here, and then you put it in the underneath the measuring head, push start, and the measurement starts. The nice thing actually is that you don't have to prepare the sample underneath the measuring head, so it's just, you know, the handling is much easier.
This is good. And is there a possibility to measure additional parameters with this device?
Yes, well, as I mentioned, you know, the standard parameters that we measure are softness, roughness, and stiffness, and then we measure, interesting for textile and nonwovens industry, the elasticity or elongation, plasticity and hysteresis. So by this we can give you information about stretch behavior and also recovery behavior of the material. With extra modules, you can measure the compressibility and the crumbleability of the material.
Okay, this sounds really good. So what could be maybe the next steps? This sounds really interesting for our company.
Yeah, normally we recommend as a first step to send samples to us. We have a good application team, and we have labs that can be conditioned to any environmental conditions, whatever you want to have. So, yeah, we would do the testing, or the application team would do the testing, and once they're done, they would prepare a report. I would contact you, and we can discuss this either on phone or via web meeting. And then if the results are as expected, obviously I think this is helpful for you, we can also find a date for an on-site visit if you're interested, either done by our local people or we come by ourselves.
Okay, and is there maybe then later also the possibility to use the device or test the device in our daily workspace?
Yes, of course. So what we offer our customers is to rent the instrument for a certain time period, for a few weeks maybe, and just to get an idea of, are the results really helpful in the daily work? How can I implement the instrument in the daily work and all that, just to get a feeling. So this is possible.
This sounds great. So then I would like to have some additional information. If you could send me some information material and contact me, and then we can discuss further steps.
I'm happy to do this. So I will contact you right after the show.
Yeah.
And thank you very much for your interest and for your time.
Yeah. Thank you very much for a nice presentation.
You're welcome. And have a nice show here.
Thank you. Have a nice day.
Thank you. Bye-bye.
Goodbye.